Hi, everybody. So we already saw trigonometric ratios where you would see three sides on a triangle. You would have different letters for the different angles, and then you try to find the sine, cosine, or tangent of the different ones. We briefly covered into missing side last class, so let's take a look at some more examples. Okay, so we're going to use trigonometry to find missing sides. It's really important to take a look and see what we're really kind of dealing with. So something like this is dealing with the angle right here. So my opposite would be over here. And if I'm taking a look at an angle here, my opposite is over here. So just remember, it may look different based off of looking at different triangles. So that's why I have more different examples of the different triangles today, because I want you to see that no matter what triangle you're looking at, it's important to determine where your hypotenuse is. That should always be given. Draw a line directly out from that angle. That's your hypotenuse. The angle that's touching it, the angle that you're looking at, is adjacent, like right here. This one, we're looking at this angle up here, and so it's this angle right here. I'm sorry, this side right here. And opposite is if you drew a line out from that angle, that would be your opposite. Okay. Okay, so let's say we had an example. So we need to determine what x is. Okay. So if we're trying to find x, we could use our trigonometric ratio. So we need to figure out what we have. So this is our angle right here. We know we have the hypotenuse. And because this 19 and this x create an angle right here, this one's going to be your adjacent one. So we need to figure out what has adjacent, what has hypotenuse. So if I take a look at my different ones, doesn't matter which one I choose, but this is opposite hypotenuse, not going to use it. Adjacent hypotenuse, that would work. Opposite adjacent, no. I have an adjacent side, I have a hypotenuse side, so I'm going to go ahead and use that. So I can set this up as, I already know that a cosine, and it's spelled fully out like this, but we use COS for abbreviation. So cosine is equal to the adjacent, which is x. I'm sorry, cosine of the angle. Cosine of 45-degree angle is equal to the adjacent, which is x, divided by the hypotenuse, which is 19. Okay, so we need to get x all by itself. So I'm going to multiply both sides by 19. That cancels out. And 19 times the cosine of 45 degrees is going to equal x. Okay, so now this is just a calculator problem. So if I do, make sure it's in degree form. So right here it says DEG. The other form would be radians, which is RAD. We're not doing radians right now. We're just going to focus on degrees. Okay, so if I have 45 degrees, I'm going to take my COS, which is cosine. Okay, that gives me a decimal number. Now I'm going to multiply it by 19. And that's going to give me 13 point, let's just say 44. And that would be your final answer. Okay, let's take a look at another problem. let's say we have this triangle right here. Okay. And let's say this is 22 degrees. We have, actually, hold on. This is 32 degrees. And we have a 15 over here. And we have a X over here. Okay, so we have our angle. This is our angle right here. The hypotenuse is over here. Our hypotenuse is unknown. So what we could do is draw a line out here, and that's going to be our opposite. And remember, this hypotenuse here, along with the adjacent, is going to create that angle. So I can already know that this is my adjacent. So, toa. So essentially, we don't know the hypotenuse. We don't have an H. So anything with an H, we cross out. And we have our opposite, which is O, and our adjacent, which is A. So we need something with O and A, and that's tangent. So tangent, or TAN, of 32 degrees is going to equal to opposite, which is 15, over the adjacent, which is X. Okay, so here's what you're going to do. So you're going to try to get X all by itself. There's two ways. You could either cross multiply, or you can multiply the X on both sides. We'll just multiply the X on both sides, and then I'll show you cross multiply in a different problem later. Okay, we want to get X by itself, so it's where you can rewrite this as X times tangent of 32 degrees is equal to 15. Now I can divide both sides by tangent of 32. Sorry, 32 degrees. That cancels out. So my X is going to equal to 15 divided by tangent of 32 degrees. So if you have a graphing calculator, you can actually just put this all in together and just make sure parentheses is around everything. Let's say you have a calculator like this. You could break it up. So, or you can put parentheses around everything. So I could do 15 divided by parentheses, and then it's going to be 32 tangent. And I don't think that worked like it was supposed to. Okay, let me try this again. I'll just do tangent of 32. Okay, so 0.6249. Okay, so I'll do 15 divided by 0.6249, and that gives me 24. And I'll just say 0.0 because there's some decimals after, but we'll just say 24.0. So this adjacent side, this X right there, would be 24 is the length measurement, okay? And let's see if I can find a good... Okay. So I have this triangle right here. And this is 68 degrees. And this is X. and this is going to be 13. Okay, so let's go ahead and we're going to figure out what we have. This is our angle here. It has to be the hypotenuse. And then if this one's coming out from that angle, this one has to be the opposite. The ones that create the angle right here is going to be hypotenuse here, and then this one's going to be adjacent. So we don't know the side length, but we do know this is the adjacent side. So this is actually a great way to start any trigonometry problem. Figure out what angle you're looking at, figure out what's the adjacent, opposite, and hypotenuse. Okay, so we know that we have SOHCAHTOA. This is my O. This is my H. So I need something with H that has no H. This has no O. So it has to be this one. So it's going to be sine is equal to opposite over hypotenuse. So sine of whatever the angle is of 68 degrees is equal to the opposite, which is 13, divided by hypotenuse, which is x. Okay, so I'll do this one for cross multiply. So when we cross multiply, we're going to multiply these together and multiply these together. So it's going to be x times sine of 68 degrees is equal to 13. And then I want to get x all by itself, so I'll divide both sides by sine of 68 degrees. Cancel, cancel. So x is going to equal to 13 divided by sine of 68 degrees. Okay, so now I'm going to go ahead and put that in my calculator. So 68, I'm going to take the sine of it, is 0.9272. Okay, we're just approximating. In a graphing calculator, you get a lot closer, but because of the calculator I'm using, I'm going to physically type and write it out. So 13 divided by 0.9272. Okay, and I get 14.02. And even if you round it up to 14, it's close enough to 14, but that would be your final answer. So we can see actually this one we did sine, this one we did tangent, and this one we did cosine. So we tried all three of them. All of them are missing different angles. So it's important to figure out what angle you're looking at. And from that angle, what is the adjacent, hypotenuse, and opposite sides. Once you know what your those are and what variables you have, you can figure out, do you have adjacent, hypotenuse, what do you have with information? And then you're able to set up your formula and you're going to solve for your variable. Usually it's x, could be another letter. Okay, and that's going to cover finding a missing side using trigonomic ratio.